right, today we're going to do something a little different. We are going to crack open a really formal, pretty technical safety document to find the amazing detective story that's hidden inside. It's a story that spans 14 years, all about a single tiny part that could cause a helicopter door to literally fall out of the sky.
So here's the question you probably never even thought to ask, but for aviation engineers, it's everything. You'd assume it's some super complex system of locks and latches, and, well, you're not wrong, but sometimes the safety of that entire system comes down to one single piece. And what happens when that one piece fails?
And yeah, that's not a what if. In 2011, it actually happened. An AS-532 helicopter just lost its cabin door in the middle of a flight. Can you imagine seeing that? An investigation kicked off immediately, and what they found pointed to this tiny, unassuming piece of metal. That single event set off more than a decade of safety alerts, redesigns, and fixes.
Okay, so in a machine as incredibly complex as a helicopter, where do you even begin looking? The whole investigation became this massive process of elimination, just tracing the failure back piece by piece until they found the one component responsible for the whole thing.
And here it is, the culprit. It's called the middle fitting. It really doesn't look like much, does it? But its job is absolutely critical. Think of it exactly like the pin in a bicycle chain. If that one tiny pin breaks, the whole chain just falls apart, right? Same idea here. If this fitting fails under the stress of flight, the door loses a key point of connection to the helicopter itself.
So the investigation showed this really clear engineering story. The original part, the one on the left, was likely to fail under what's called static load, which is really just the constant force and vibration of flying. The solution was what's called Modification 0726841, a totally redesigned beef gut fitting engineered to handle all those forces. That became the mandatory fix.
And this is why it matters so much. This is a direct quote from the safety directive. It's not just about, a damaged helicopter. It's about the potential for real catastrophic harm. The stakes just could not be any higher, and that's why the response had to be so incredibly thorough. But they didn't just invent this new reinforced part overnight. Aviation safety is an iterative process. It's all about steps. And the road to a real solution here was long and winding, leading to what everybody thought was the final fix. So right after the incident in 2011, bam, regulators put out immediate flight restrictions. A year later, they required extra inspections and warning placards as sort of a stopgap measure. It wasn't until 2015 that the fully redesigned part became mandatory for everyone. And for almost a decade after that, it seemed like the problem was solved. But then, 2025 happened. And this is where the story takes a really fascinating turn. Because the engineering problem, the physics of it, was solved. But that accidentally introduced a totally new, unexpected problem, a human one. You see, even if you have the most perfectly engineered fix in the world, a system is only as strong as its weakest link. A reinforced part can't protect anyone if it's sitting on a warehouse shelf instead of being installed on the helicopter. And that is exactly what regulators started to discover. The new problem wasn't about design anymore, it was about logistics, a supply chain issue. Somewhere in this huge global parts network, a mistake was made. Old, faulty fittings got mixed in with the new good ones, which means you could have helicopters that everyone thought were safe, but they actually still had the original dangerous part installed. This discovery is what triggered the brand new directive in 2025. It wasn't enough to just have the fix anymore. Now every single operator had to go back and physically prove they had the right part installed, and they were told to do it fast. The new directive was actually simple, but incredibly strict. Step 1. Inspect every single affected door. Step 2. Identify which fitting is actually in there. Step 3. If you find the old part, you have to take corrective action right away. And then Step 4, the crucial final step, re-identify the compliant doors with a new plate, creating a permanent visual proof that the check has been done and it's good to go. So what was the deadline for that initial inspection? Get this, 7 days. That's it. A 1-week timeline. That alone tells you just how serious the regulators considered this risk to be. And if a maintenance crew found the old, faulty part, the consequences were immediate. First, you had to install a placard on the door. Second, that door was effectively grounded. You could not operate it in flight. And from that moment, a new clock started ticking. Operators had 110 flight hours, or 6 months, whichever came first, to get the correct part installed for good.
So let's zoom out here for a second. This whole thing is a story about one small fitting on one specific type of helicopter door. But it's also a perfect case study in the relentless, totally detail-obsessed world of aviation safety. It all comes down to a bedrock principle in aviation, captured in documents like this. They're called Airworthiness Directives, or ADs for short. And you have to understand, these are not suggestions, they're not recommendations. They are the law. They create this legally mandated continuous process of finding a weakness and then ensuring it gets fixed across the entire global fleet, so that a problem that happens once never happens again.
And that really leaves us with a final thought. We just went deep on a single helicopter door fitting. It makes you wonder, doesn't it? Every time you fly or drive your car over a bridge or even just ride an elevator, your safety depends on thousands of these tiny, unseen components. And every single one has its own story of design, of failure, and of improvement. It's this whole hidden world of engineering that is quietly and constantly working in the background to keep our modern lives in motion.